going to answer D for our last one that we did. All right. Which of the following elements is not one of the four most abundant elements in the human body? Well, remember that he told us that the four most abundant are C, H, O, and N. So just cross off any that are not that, which is zinc. So zinc is not an abundant element in our body. Okay, number 12, we're looking at an isotope of argon. Now remember what an isotope is. An isotope, all of the elements can change the number of neutrons. And changing the number of neutrons makes them gain or lose mass. You can think of it as like gaining or losing pounds or weight. And so we see isotopes written in two different ways. We see it with the atomic number. And let me look up argon. What is argon? I think it's just Ar, isn't it? Oh, let's see. Where do we find argon? Okay, argon is 18. So he's always going to have 18 protons and neutrons. He's always going to have 18 protons because that protons never change. That's their name badge. And then the mass, as we would see it written here, because it's 38, it would have a mass of 20. So you can see isotopes written like this, where you have the protons down here, and you have the mass up here. And then here's the other way it can be written, where it has its name spelled out, and a dash, and a 38. This 38 right here is the same as this number right here. This is telling us the mass of this isotope of argon. And so all you have to do is go and find argon on the periodic table, find its number of protons. So we know argon has 18 protons. And actually, we don't even need to do anything with the mass because it's asking for protons and electrons. This isn't an ion of argon. Ions are when they can lose or gain electrons. This is an isotope, and isotopes gain or lose neutrons. So if it has 18 protons, then it's going to have 18 electrons. Looking at B. Okay. For main group representative elements, what do elements in the same group have in common? So remember that the groups, let's go back to this guy right here. Let's erase all this. Okay, so these are our groups. Remember, these columns are our groups. So all of these guys are in the same group. And it wants to know, what do these have in common? What do they share? They share something very special and easy for us to figure out what their charge is when they are an ion. And that is the number of electrons on their outermost shell. And remember that the outermost shell is called the valence shell. So everything in a group shares the same number of electrons on the outermost shell, or the valence shell. They don't share the same number of shells. That would be a period. They don't share the same number of neutrons because that changes from element to element. And they don't share the same number of electrons because, remember, every element kind of can give or take some neutrons, give or take some electrons when they're an ion, give or take some neutrons when they're an isotope. So those things do not stay the same. The number of shells does stay the same, and they do share those in a period. But in a group, they share the same number of valence electrons. So let's look at that real quick. So that's telling us that everyone in this group, let's do this group right here. Everyone in this group shares the same number of valence electrons, and that number for group 1 is 1. Everyone in group 2 shares the same number of valence electrons, and that is 2 electrons. Okay, let's do one more. What is the charge on chromium in the compound CrO3? So let's look at our periodic table again. Chromium is right here. So he is a transition metal, because remember all of these guys right here are transition metals. These yahoos though, these have set charges. But everything else is a transition metal. So we're looking at chromium. He's a transition metal, so his charge can change. And the only way we can find the charge on a transition metal is to look at the element to whom it is bonded. So we have chromium. We do not know his charge. We have oxygen. We do know oxygen's charge. It's 2- because oxygen is in group 6, which means it has 6 valence electrons, so it needs to gain 2 electrons to have a full octet, which will give it a 2-. So if we have 3 oxygens with a 2- charge, let's draw out how pK draws it. We have 3. That gives us a total charge of 6-. Well, we have 1 chromium, and we need to neutralize a -6. How do we do that? We do that with a +6. So we look at how many chromiums we have. We have 1 chromium. Therefore, this chromium has to be a 6+ in order to neutralize the 6-. So that would be A.